The following is from Summer 2007 Math 227 Final, number 2, Part C and Part D. Part C, a box contains 5 quarters, 3 dimes, and 2 nickels. In Part C, create a probability distribution of number of nickels selected for a procedure of selecting 3 coins without replacement. Now let's define a variable first. This time let x be the number of nickels selected. Okay, I would really like to use n actually, but I don't want us to confuse with the n for the size of a population, so I use x right now. Okay, now the question is we need to create a probability distribution, which implies we need to create quote-unquote a table. Okay, we need to create a table. Now notice that how many nickels do we have? We have 2 nickels, right? And then out of 10 coins. So if I look at my pot here, I have 2 nickels and the rest are not nickels. Okay, let me put that notation, not nickels. Okay, now if I select 3 coins without replacement, you can see that the outcomes for this x will be either no nickels, 1 nickels, or at most 2 nickels. It will not be 3 nickels selected because you only have 2 nickels, right? Okay, so this is my outcome. This is the probability to the corresponding outcome when x equals to 0, x equals to 1, and when x equals to 2. Let me use a red color to distinguish that, because this will be quite a long process. Now, to have no nickels means from those 2 nickels you choose nothing, and from the rest of non-nickels you choose 3 over 10 choose 3. Okay, we will compute this later on. Now, to have 1 nickel means from those 2 you choose 1 of them. From those 8 non-nickels you choose 2 non-nickels, right? Over the total of 10 coins you choose 3. And now lastly, to choose 2 times 8 choose 1 over 10 choose 3. Let's compute each one of them. What is that equal to? 10 choose 3, you will see that's equals to 120. 2 choose 0 is 1. 8 choose 3 is, let me see, 8 choose 3 is 56. So this is 56 out of 120. Now this one here, 2 choose 1 is 2 ways. 8 choose 2 will be 8 choose 2 is 28, I believe, over 120 again. This will be, oh, again 56 over 120. Okay, this is 2. This is 1 times 8 over 120 equals to 8 over 120. Okay, now notice that the total is supposed to be 1, right? When you add them, you will get 120 over 120, which is 1. Now that's the probability distribution. Now if you can simplify this, it will be nice. Again, if you can simplify this, it will be better. For example, I can simplify the top and bottom by, I think I can simplify the top and bottom by 8. Let's see. Yeah, if I divide by 8, this is 7 over 15. This is also 7 over 15, and this will be 1 over 15. And they add up to 15 over 15, which is 1. Okay, now do you have to simplify that? You don't have to, but I strongly suggest you to simplify that. If you don't simplify that, then change it to decimal. Okay, and when it comes to decimal, 5 decimal places. Now that's for part C. Let's move on to part D. in part D, the question is extend the probability distribution created in part C to compute the expected number of nickels and its standard deviation. So what I will do is the following. I will redo the probability distribution so that I can extend it. Part D. This is my probability distribution. But remember that I have extension in mind. Okay, this is the probability column. This is the first extension, and the second extension takes 2 more columns. Okay, this is my x, the probability of x. Now this is x times the probability. That's the first extension. The second extension will be x squared, then x squared times the probability, right? 0, 1, 2. Here I have 7 over 15, 7 over 15, and 1 over 15. I basically, this part here, I copy from part C. And of course the total is 1, right? That's what we start with. Now I will extend this to find the mean and the standard deviation. Okay, now when I multiply this, x times p is 0, x squared is 0, so the x squared times p is also 0. Now this one here, x times p is 7 over 15, x squared is 1, multiplied by the probability is x squared times p is still 7 over 15. Here, if I multiply, I get 2 over 15. X squared is 4, multiplied by the corresponding probability is 4 over 15. Easy, okay? Now, then, this will be 9 over 15, and this one here will be 11 over 15. Now, the mean of this distribution, the mean of x, is equals to 9 over 15, which is 3 over 5, or if you want to make it decimal, that's 0.6. Okay, while the variance of x is 11 over 15 minus 9 over 15 squared. I hope you remember the formula. Oops, it's not visible. Okay, let me just use this. Okay, and this is equals to 11 over 15 minus 81 over 225. This is 165 minus 81 over 225. I think that's 84 over 225. I believe I can reduce by 3. If I reduce by 3, 84 becomes 28, and this will be 75. That's the simplest I can go to. Or if I want to make it decimal, I get 0.37333 in decimal. Okay, now this is from Fall 2007 Math 227 Final number 2C and 2D. This is. Hold on, honey.